Good afternoon, everyone. Are you doing well? How was the day? Good? Okay, that's great. To be sincere, well, every year I really enjoy the NIC conference. It's very alive and there's a lot of nice things happening. But enough that, because we've got a lot of subjects to talk about, and they're going to be hopefully interesting, maybe sometimes a little bit complex, but definitely from security field. Let me introduce myself. My name is Paula Januszkiewicz, as you see on the slide, and what I do for a living is I'm a penetration tester, or as some people call hacker, as in our team we actually call it a researcher. So that's what I do. Our team consists of 8 people right now. We do different kinds of consultancy in security field. And as a person who I think has something to do with security, I have also access to the source code of Windows. And actually this 2 days research that I will be showing to you, it's sometimes in some places relying on the access to the source code of Windows, but for some places we not necessarily have access to. So this is actually a research. And we're going to talk about credentials. So it's a pretty cool subject because there is an idea of cached credentials. Everybody uses that. Oh, don't log on here, log on there, and so on, because you're going to cache your credentials. And everybody says so. And I was like, one day, okay, guys, like, what does it mean, cached credentials? Like, are credentials really credentials? Are they really cached? Like, what's the point? So we will, of course, talk about that. We will start with the a light point, and what we will do, we will going to discuss all the different places where credentials are actually stored on the disk in a different ways, in a different places. And then we're going to move to the operating system case. Actually, we've got a case study, 2 types of case studies, where we will recover users' data. And this is something that is actually relying on our research that took over 6 months. So I'm super happy to show you what we have discovered and why the whole identity and privacy is absolutely violated in the infrastructure right now. And I'm quite positive about it, but effectively it is actually a pretty serious subject. So from the perspective of the presentation, you see this yellow kind of like brain over there. Don't get me wrong, I will not try to be funny in this session. Yes, this session is about a serious subject. So if you expect entertainment, not on this session, I'm sorry. There's a lot of interesting stuff to talk about. So just focus, enjoy. And after the session, I'm super happy to answer, as you know, maybe from the pre-con as well, all the different questions. Yeah, so you can definitely ask them. Anyhow, there is a Twitter. I also speak on different events if it's about myself. So if you did not see me before, and I was rated a #1 speaker at Microsoft Ignite last year. But I always say one thing, that it doesn't mean that I'm a good speaker, because I mean I don't know that. But definitely, I think we talk through the important, interesting, and definitely practical subjects. Nobody leaves our sessions with empty hands, ever and ever. So there's always some links, some tools, some giveaways, and so on. And this first link that you see, it is a link where we publish all of the different tools, all of the tools that we wrote for this session. And you're going to see, because there's actually tens of tools that we wrote for this session, you're going to find in that place. I'm also running the workshop with glass paper on the 22nd of January, which is in 2 weeks, and it's a hacking secure Windows infrastructure. If you want to know more, you're definitely invited, and it's 5 days of hardcore, so prepare mentally for that if you are interested. Regardless, let's start. What is interesting about the disk is that, well, there's a lot of things that are written to it. Sometimes, well, we know when we save the log files and when we save our documents and so on, but there's a lot of things that we don't know about, and they're kind of hiding. Now, my question was, when I was preparing for this session, is there any like a juicy place in the drive? And of course there is, but I want to know the juiciest, yes? Not like forensic stuff, but even like deeper. Like, we need to actually write tools to decode, deconstruct different types of information. Are there any? And obviously they are. One of the most juiciest places right now in Windows, it's something that is called Data Protection API. And Data Protection API was claimed to be broken in 2010 on Black Hat. And we were like, whoa, this is really exciting. But the very nice guys did that, but they did not show really how they did it. because it's dangerous. Now, did they really do that? Yes? Okay, so there is actually some great, amazing research that they did, but we continue from that, and as far as I know, we are the first group in the world that discovered that, so hopefully you're gonna hear some news today. If it's about the agenda, it's very simple. As usual on my presentations, we're going to talk about, at the beginning, different data chunks that are stored on a drive that contain juicy information, and the second, system scenarios where, for example, we store credentials in system. I mean here, for example, these cached credentials. I'm always loving when I say it, because these credentials are, first, not cached, second, not credentials, but we always call them cached credentials, yes? And these are the ones, just to, of course, reveal a little bit of secret right now, that we use when we log on to the operating system when the domain controller is not available. Yes, and the question is, what's that? So let me start. Interesting so far? Like, does it sound like, apparently you will not be there. Yes? Are you guys there? Okay, perfect, perfect. So, when we think about what is stored on the disk, well, there are plenty of things. We've got new technologies that were brought to the field, for example, things like deduplication, yes? In general, we've got also different types of temporary files. When we browse websites, question is where they are stored. What about, for example, the private mode that is used in Internet Explorer? Is it really that private? Yes? Definitely not. Some of you are like, no, definitely. Exactly, it's definitely not private. I would like to, of course, actually start from that and show you how much it's not private. But long story short, there are also different interesting structures that we can play with on the NTFS file system. For example, there are different chunks on the disks, on the disk drive, that are large, with 1.5 kilobytes, and unfortunately, whenever even you do cipher, so you encrypt the data and so on, this data, it's not encrypted. Because this is actually written in the metadata of the drive. So it's nice to know that if someone gets this data and you've got a small file, for example, passwords.txt, yes, which is usually a small file, when you got that and you save it on a disk, and even though you delete it, is it really deleted? Yes, and I can tell you no. But of course, this session is to dig in deeper and find out how to check. So let's start from the interesting things that are related with, of course, Internet Explorer, as I said, and the session is covered with demos. So prepare for hardcore, and yep, I'm hoping to serve you that. So let's start. Secret spree, and then we're going to reveal different kinds of interesting objects from the disk. Let's start from the pleasant one, which is the, as we see, in private. It's kind of funny always, because we're always wondering like why Microsoft invented in private mode, and they have explained that they did it because if you want to search for the present to your wife or husband and you want to give a surprise, yes, that's when you're going to use the private mode. Well, I kind of disagree with that. I think it's used for the different reasons. But in general, let's have a look. So this is Vimeo, yes, and in general, not a big deal. What I will do, just to search through, I'm going to type here my surname, because there is some kind of a presentation in 2011 that I was delivering, not a big deal. But at the same time, before I play this presentation, I'm running underneath process monitor. So this is nothing but a procmon. In our team, we have a saying that if you have literally nothing to do, like you are bored, like you were like, weekend, Sunday morning, you're like, oh, what are we going to do today? Maybe cinema or something. Answer in our team is always run procmon, because there's always something interesting to do and to find. And definitely, procmon allows us to troubleshoot absolutely most of the cases at our customer sites. I know you know the tool. I know, because like procmon is quite famous, but with the good tools, with the good options inside, we can do a little bit of magic here. So what do? First of all, I do not monitor it, so I have to monitor it. But before I press capture, I would like to show you a filter that I have created. And this filter covers two things. One, process name is explorer.exe, because that's exactly where the private mode is running. Second, and I always say the favorite filter, category is right. Oh my gosh, that solves a lot of things. And for our session is perfect, because I want to know literally everything that is written in the disk. I would put it this way. If we're talking, of course, about what is written on the disk, we'll be sitting here until Friday. If you've got time, I do. Yes, in the morning, you can actually attend the 9th session in room number 1. That would be perfect, yes. But I guess it's not the case because there is a beer day today, but anyway. So we've got these two filters. I can click cancel because they are there anyway. Let's start capturing data. Yes, and what I will do here, I will, simply speaking, just play this presentation. Yes, so not a big deal. But what I want to show you is that if we do that, so it's running, you don't hear it because it's muted, and that's fine. I was young and stupid. Basically, when we move further, what we can see over here, so these temporary files, yes, these are the files that are exactly representing us. So this is growing, yes, this is representing us, the streamed video. So my husband is kind of busted right now, because if he would like to watch something in a private mode, yes, because everything is written on a drive. So private mode, it's not private at all, because everything is there. We could be, of course, wondering, okay, can I like see that? Well, definitely. You can do jump to, and what will happen is that you will be able, and it actually opened over here, yes, to see different chunks of data, yes, that represent us different types of activities within the well, the whole situation. Yes. So that's the whole point. Everything that we do is actually logged, and even in private mode, it's not in private. And that's, I think, this is me. Like, you don't want to see that. Okay. This is pretty much the situation, that everything is safe on the drive, and it's just a matter of appropriate tools to find those things. Okay? So, whenever we think about the other things that are on the disk drive, let's start actually from quite an easy thing, because we are talking credentials, yes? What do we mean by credentials? Well, when we think credentials, sometimes we think passwords, sometimes we think hashes. So, question is how the credentials are stored within the domain controller. Of course, we know that in a domain controller we do have an ntds.did file, and ntds.did file is nothing but a database. And that database has tables, or as every database, and here comes the big question of the universe: what kind of tools I can use in order to extract data from this database, besides Active Directory users and computers, but it's not, of course, everything. And for example, am I able to extract the hashes? And why and how do I extract the hashes? Well, here comes a small explanation of that. For that, I have actually prepared a Python script that is written by my colleague Csaba Barta. He's from Hungary. But before we do that, what I would actually do, I need to copy the body that I will be working on. Because if I want to extract the hashes, I need to have a copy of ntds.did, so not a big deal. Now, of course, we can easily guess that if I want to copy, for example, let's do that. Copy, and then we're going to do C Windows system, so Windows NTDS, yes, ntds.did, yes, and I want to do that. Then we've got a situation when we got a non-sure handle, which means that I'm not able to access this file because there is only one process that can be attached to this file. So we got a little problem, and I'm sure you know. What's the way of copying that? Volume shadow copies. Thank you. Exactly, this is the answer. So let's do that quickly, and then let's get access to those files. Let's extract this data. So for that, we're going to use VSS admin, and then create shadow, yes. And then we're going to do for, and then in our case, it's going to be a C drive. Lovely. So that creates us a shadow copy. And this path over here allows us to be accessed directly by the copy command. Yes, actually, I'm going to go to the folder when I need all those things. So in our case, it's going to be Python, and I'm going to put it in a ESDB export. This is one of the community tools that is written in order to extract the tables from the ntds.did. So we are talking maybe forensic, maybe not. Actually, it is a little bit of forensic, but I call it just internals of ntds.did. So let's do that. Yes, copy. And to that path, we're going to copy, of course, and let's paste the whole thing. So in our case, it's going to be Windows, because it refers to the root drive, ntds, and we've got our ntds.did. But the problem with this tiny little file is that if you open it in Notepad, it's a mess, yes? Now, is this file enough to extract the juicy information? Absolutely not. Sometimes we hear like, oh, we're gonna steal some database. Go ahead, steal mine, no problem. But as long as you don't have a system hive and security hive, you are not able to decrypt information that is in the both some database and also NTDS.dit. It works pretty much the same. It's just a bigger database. Okay, so let's have a look. ESDB export. So in this particular case, we're gonna of course work on it with our NTDS.dit. But before we do that, two more things. Yes, so I was talking about system and security. So let's do that. And this one is placed in Windows System 32. Yes, and then we've got config, and then we've got system. Yes, and then we've got security. Lovely. And then we've got, if you want, there is also on domain controller some. Yes, that's not a problem. Now, ESDB export works directly on ntds.dit, and it will create us a folder where we've got all the tables extracted but not decrypted. In order to decrypt it, we need another tool. So let's do that. So these tables are getting extracted. As you see, it takes a little while. If you got like 5,000 objects, it's going to take a couple of minutes, yes? And the next process of getting the hashes out, it's going to take about maybe 20 minutes, yes? So this is the whole operation. And after that, what we're going to do, we will, of course, extract those hashes. So we got that, lovely. And let me actually go to this folder. This is our ESDB export, and we've got our ntds.dit export, and we've got our precious files here. So I'm going to copy them, and I'm going to put them into the next folder where I will actually extract those hashes. So they're going to be decrypted by the key that is spread across the system hive and security hive. So just a small summary, yes, if you want to get the knowledge right now, in order to get the hashes, you need to get the system, security, and SAM or ntds.dit. Now you're ready to go, okay? So, perfect. Now it's time to have fun. So we're gonna go back. Let me clear the screen and ntds-x, and then we're gonna use this Python script, which is called ds hashes. Ah, it was there. Let me move this back. Here we go, ds hashes. And then we're gonna refer to ntds.dit export. So this is the place we had all those tables. And then we're gonna link two tables, data table that contains data, and ntds.dit export, and link table that contains information that is actually useful to decrypt. And then we will specify what we would like to do. Password, hashes, yes, and then we're going to specify system hive. So that is actually in the parent folder. Lovely. So this operation happens right now, and we are extracting the, well, first we are scanning database, searching for different objects and so on. When this is over, what we will do, we will start actually decrypt the database in order to get the hashes, and that's of course fantastic material to check out on your guys if for example, someone is reusing passwords in the company. This is my favorite test. We could be like, oh, this is not ethical. No, it's very ethical because you never know the password. We are talking hashes here, yes? But if you got administrators, guys, I found out many times that username for you as a user and administrative accounts of administrators, sometimes they got the same password. Oops. Yes, so you can always find that out, and if the hashes are the same, bring it out. Yes, so this is one of those ways. As you see, it takes a little while. My domain is not big, but as a result, we've got two things. Yes, NT hash, as we call it. So this is this one on the right side, and we've got LM hash, which is on the left side. And technically, for security reasons, this should look exactly like mine. Control C, Control V. You have this. You're supposed to have the same. It means it's empty. If it's not empty, you're in trouble because your passwords are breakable in seconds. Yes, you're using technology from before year 2000, which is old. Yes, so this is what we are talking about. Okay, so this was the first thing. Yes, these are the hashes. Now, what we will play with is actually a pretty new technology that is related with, well, data deduplication. And when we talk data deduplication, I would like to actually show you something interesting, because when we turn on deduplication on the drive, question is, when we delete the data, are the chunks deleted? Just to summarize, what's the deduplication? Deduplication is a technology that was introduced in Windows Server 2012 for storage, so that whenever you've got similar files, what you can do, you can actually store a single chunks of those files, and out of 3 files, literally store 1, and for the other files, just put the reference to the files so that these references, they don't take space. Very nicely working actually, but tiny little case here. So let's have a look. First of all, I have a volume. That volume, it's on the F drive, but in order to work with that application and the system volume information, I need to be elevated to the local system, okay? So in order to do that, I'm going to get to my tools, and I'm going to use, obviously, PSExec. So this is by Mark Krasinovich, with the 3 parameters, 3 favorite parameters: SID, S to run it as a system, I to make it interactive so that I am able to communicate with this process, D to run it in a separate window. Bang. Of course, in order to do that, you have to be an administrator. On the precon, I was talking about the privilege in operating system that is called impersonate a client after authentication, and this is exactly the privilege that we use here. Yes. Okay. Now, interesting stuff. Basically, when we are speaking that application, I got a drive. Well, this is the folder where I will load the data. Just to show you here, I just have like a VHD and so on. So this folder is empty, and I have also another drive which is for the application. This drive is H, yes, and over there I have 2 types of files, yes. One is the secret data, another one is a secret data copy. Actually, let me do this in GUI. What I will do, I will launch this, like we've got this application, secret data, I get a file, it's called AAA, a very sophisticated name. I'm opening it, and this file has that content. Yeah, so we store some kind of password, some kind of secret information, whatever, something valuable from the business perspective on the deduplicated drive. Now, what will happen is that, well, this data was deduplicated because, well, I copied that, but what I will do, I will like select that and I will say, hey, I don't want that anymore. Like, just like be gone. Yeah, so thank you, goodbye. Now question is, what is stored on a drive? What about those chunks, yes, that we were talking about? Are they still there? Is someone still able to pull this data out? And, well, let's see. So what we will do, and this is pretty interesting. Well, first of all, let's go, because the path is pretty interesting. System volume information, it's a hidden folder, but when you just tab it, it comes out. And in the system volume information, we've got dedup folder. So let's get to that, because probably it has something to do with the application. Now we're gonna, of course, do that there, and then you've got chunk store. Chunk store sounds like a store with chunks, so definitely this is something that is interesting for us too. And then moving forward, we've got something that, well, it doesn't show anything, yes, but if we do dir and a, then there is a folder that is called with this like brackets. So this is also pretty interesting. Let's get there. And the path is getting really long right now. Well, let's see what else we've got. And if you do dir, we've got, of course, some kind of a dedup files over here. Yeah, so this is pretty interesting. But can we, of course, do again dir/a? And is there more? Well, as you see, there is a data folder. So let's bring it on. Data folder, yes, the same, dir/a, anything else, and this is it. This file ccc, we can see that is actually the biggest one. So probably there is something interesting. Like, can I find out? Sure, let's do that. So copy. Well, if you wondered how I figured that out, this is pretty much what I do in the Sunday mornings. Yes. So why someone will actually get to this folder? Well, why not? That's the answer. So let's copy that stuff, and we're gonna copy that to the C dedup folder, and this is pretty much the place where we want to go to. So this is our dedup folder. Let me clear it. We are done. Now we've got our file ccc, In order to find a little bit more information about it, you can always open it in Notepad. Old Notepad works pretty often very well, but now let's be a little bit geeky here and let's do something nicer. What I will do, I will search for strings in this file. And in order to search for strings, I need to use the strings tool. So in order to use the strings tool, let's launch it. Strings. And strings will work on, in our case, minus n10, because I want to have long strings, so to say, that are at least 10 characters long, and they're gonna be in our DDAP folder when we've got our files like this. And if you are wondering what is in chunks, this is exactly our information that we deleted. Lovely, right? So on and so on and so on. There's so many things. Now, we could be wondering, is data deduplication bad? No, it is actually a pretty good solution, but this type of old chunks, they are clean out when we, for example, launch a garbage collector on the top of the volume. So as long as you do that often, that's nice. If you don't do that at all, then, well, of course, all the data that's going to be deleted, you're going to find in this particular file. The technology is awesome, but there is this thing that you should definitely know about. Okay, guys, now, when we think about different other technologies in the drive, like what is interesting from the deletion perspective. When we delete something, for example, we've got some file that we don't want other people to see it, yes, does this file stay on the drive or not? Well, we could always recover things, but I want to show you even something more interesting, how NTFS behaves when the file is smaller than 1.5 kilobyte. It actually puts it in a metadata of the file instead of the data of the file. So this is funny because when we work on files, we work on data of the file, not on the metadata of the file. That actually makes us a little bit more vulnerable that whenever you think you deleted something, you truly didn't if the file is less than 1.5 kilobyte. Let's prove it. So what I have over here is the console where I have, well, as you see, a couple of scripts. I'm going to run a second console as an administrator because I want to actually use the NTFS walking tool, which I'm going to explain in a second. So in our case, that's going to be the F drive. And what will happen? Well, first of all, I have a script. It's called wipe it. And that particular script, wipe it, I'm going to fire up, and it will delete password1 file. Let's do that. So that's exactly what happened. And, well, the file is just deleted. And what is the case is that over here, we can go and run recover, and in order to recover that file. Now, where the file is going to be recovered and how does it work? That file will be recovered, actually, on my desktop. There's going to be created an undelete folder. And that undelete folder, let me pretty much go to the certain path. And I will show you this in a second. Let me do that with the shift. And then I'm going to copy that as path. And then I'm going to open another command prompt where I will actually go to desktop. And then I'm going to go to the undelete folder. Yeah, so this is the one. Right now I do tab. And that doesn't exist. Yeah? So let's pretty much recover this file. And then it says that, well, there was a folder that was created which is called undelete and so on. So if I do this right now, so let's do that one more time. Let's see, because it should be there. Undelete, where is it? On desktop? No. What is wrong with this console? Let me see. Oh, where's my folder? It says the license expired. Well, this is not true. Okay, sorry, my fault. Oh, this is not very professional. But what I would like to show you, let me bring it up, because I do, of course, have a license. This is basically, so this is the NTFS walk license. That's the case, because I have, yes, exactly, that's what happened, because I have cleaned this drive, yes? Well, let's bring it up. And we will be back in a second, because I have to copy that particular license actually on the drive, and this is the scenario. Not good. Let me see. This is the NTFS work license, which I have. Yes, should be fine right now. Very good. I'm just going to copy this on the drive in the folder, and then it should be all good. So okay, this testing license go out, And let me do that one more time. Lovely. So we got it. Okay. Yeah, this is the license that we've got, and this is my license. And then we've got our undelete folder. No, what's this? Come on. Well, apparently I will need to show this to you a little bit later, because it looks like I may not have it in a place that I want to. But that's not a problem, because we will find it and we'll be all good. It's just a matter of finding it. Let me do that. Okay, here we go. And this is the NTFS walk, and it has 11 in the code. Well, in a worst case, I will just get back to this demo in a moment, yes? This is, what's the tool? Maybe I'm going to tell you a couple of things about the tool. Well, the tool itself is actually pretty nice. It was created by the guy, well, from TZ Works. That's pretty much his name. And that particular license, or that particular tool, allows you to walk through NTFS and recover, well, anything that was from the certain file system. Yeah, so whatever was deleted, then of course you got that kind of information. Let me see if and what we can do. Yeah, lovely. I have everything right now, so we are back on track. So perfect. Let me copy the license, and we should be all good right now. Well, let me try at least, because I think this license actually I gave it's a good license, but there is something wrong that went with that. No issues. Let me see. License is here, and we're gonna bring it back one more time. Delete the license that I had before. Put the original license, and let's try for last time. Yes, we got that. It is registered to Paula, no, that's me, and desktop and so on. So it looks like it actually came out. Yeah, let's see. In a worst case, yes, we got it. Yay, finally. Okay, good. So we've got our undelete, cd undelete, but this is kind of like, okay, console. No, 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 no. Actually, I can show you because I have it created right now. Yes, this is the one. Yeah, it's there. It's just that it's kind of funny because if I do undelete, now it came. See, Windows. No, I don't want to say it. I actually like this operating system. Okay, so good, good, good. Well, let's use this GUI maybe then. This one is empty, and that's fine. Yeah, this one is empty too, so we don't see here much. Let's see why. The next thing, we will of course delete the second file, and then let's try to recover it one more time. Maybe we're going to be a little bit more lucky. Oh, that looks juicy, yes? And then we will be able, of course, to get more information. Now, what I will do, I will actually encrypt the data. Let me check what else we've got and if we have more results here. Oh, this is the one. Lovely. Catch all. Oh, these are the data that we had. And all those tiny little chunks that were deleted, yeah, so these are the ones that I actually deleted, yeah, so this is the one that is a password2.txt. This is what is contained, because also this HTML files, this was actually the license that I had, so I deleted it and so on. Nothing can be hidden here, and only small chunks that we've got can be recovered. And what is also interesting is that when you even overwrite the data, yes, that's not a big problem, because every single time you do that recovery, you can see that even if you have encrypted the data, yes, even though with such situation, the small chunks are being recovered, and we can go again to undelete. This is the new folder being created, and we can check that out and catch all, and there is of course some kind of an information that was deleted too. Apparently there are some Chinese guys on my computer, yes. So that's because I already deleted the previous one, so that's why we can see this way. But in general, when we've got those small chunks somewhere, this is of course information that even though we encrypt data, it's recoverable whenever you use the tool. And actually I use this is not the journal parcel, but the other one I use for that the tool. If you check out from TZ Works NTFS walk. Yes, it's not a free tool, unfortunately, but it's definitely good enough to have fun. Okay, so we are almost done with that, but a little bit more credentials, yes, where we can find them, what else is on the disk, and what about the SAM, system, security, what about IIS? So is there any interesting data that we can find? Definitely yes. I was at that first slide also showing a file that it's called credhist. And credhist file is the interesting file that we can find in the user's profile. And credhist file contains history of our credentials. Now, let me show you something. Every time you change the password, what happens is that your credentials are actually cached in a way in the credhist file. This credhist file is stored in your profile. Now, where is it in the profile? Let's bring it on. Simple story. When we do percent updata percent, we go to updata roaming, and of course we've got Microsoft protect, and this is the file where we have it. Yes, this is the credhist. Now question is, can we get access to it? So I can tell you right now that in the internet we could not find a tool that will be able to reverse engineer the credhist file, but when I see a file like that, the obvious reaction is I want it. Yes, I want to know exactly where there is. Like how those credentials are stored. Are they encrypted or not? Like are they in a clear text? Why they are stored? I can tell you, so that if you've got a scheduled task created and you've got it on a certain account, and for this account password expires, or service for that password expires, question is, well, what about that particular service? Will it run or not? So answer it, it will definitely run, because there are cached credentials into the credhist file for such situations. So this is actually pretty nice. And your service will run for 90 days. So now, I would like to show you something. The tool that we wrote, it is called Credhist Decrypt, CQ Credhist Decrypt. And that particular tool leverages, of course, one thing. First of all, we need to give a path to the credhist file. So this is from the user. And in order to get access to that, you have to specify the user's password or the hash, because this file is actually encrypted with the password, effectively with the hash is one of the factors, so that you are able to get access to such. And if I do this, I have the information out. This is pretty much how many times I have changed the password. What do we have? And this is actually pretty amazing, I will tell you, is that we have here two things. One is the NT hash, and another one is the encrypted PWD hash. Yes, in this case I don't get the NT hash, but the encrypted PW hash, it's a SHA-1 version, SHA-1 edition of your password. Yes, so your password is not encrypted. It is actually hashed in many different ways, because we don't know which technology in Windows eventually will use what, your hash or NT hash, as we should say it technically correctly, or maybe SHA-1 or maybe something else. So these values are stored over there. What is actually interesting, if you want to talk, we can talk on a break, that in this particular file, it's not that I just decrypt it and it's one and we got it. It is actually that one chunk affects encryption of the previous one. So we've got many chunks, as you see. So technically, in order to decrypt it, you need to know the password. And for the another one, you need to know the password or hash, effectively hash for another one and hash for another one and so on. Yes. So our tool does this kind of in a linear way. So this is the approach. Now, when we think like, okay, I got this server, where else I can find passwords? Yes, where else are they? Well, simply speaking, we can find them very easily in IIS, where we've got our application pools. And we've got our, for example, Freddy account, and I'm obviously interested where the password is. We could be expecting that the password will be actually in application host config, because this is where we store application pool settings, but application host config stores that password, but also in encrypted way. Encrypted means you can decrypt it. And what is interesting in that particular scenario is that if we, for example, and let me take the console here, we're gonna get back to our Windows System 32 inet srv, no inet srv, yeah, enter, and then we're gonna go to config and notepad application host config, and I'm gonna search for Freddy, you can see that password for Freddy says IIS, Windows Activation Service, so WS, only AS, so symmetric encryption provider. So when I see this, it's a clue. It's a fantastic clue that says, hey, you have to ask this service, because probably that service knows. So let's do that. How do we do that? Easy peasy. How do we do that? Let me show you. We do it this way. We use appcmd, yes, and we list app pool settings. We're gonna choose application pool that is actually running by that particular account, so by Freddy, so we can check it out. And for Freddy, yes, in this case, let me take this out, it is app1, yes, so this is perfect. Full screen, and that's a little bit more convenient. Lovely. So this is app1, and magical switch text and asterisk gives us all the settings about application pool, yes, including in a clear text the username and password of that user, yes. And there are gazillions places like that. I'm not finished. Okay, so we're gonna bring it on now. Interesting stuff. Have a look. This is not interesting. Now it's coming. What we have in basically in the whole settings in the new IIS 8, we have the setting when we go to the server side where we can configure the centralized certificates. This is the new solution that allows us to, for example, load different HTTPS certificates and run multiple HTTPS websites on a single IP at the same time. So if we do edit feature settings, as you see, I got here 2 types of passwords. It's kind of funny because when you see dots, it means it's decryptable. Yes? So now question is how? So let's see. What we will do, first of all, and this is going to be interesting, I will actually, let's go to desktop and I will show you something. We will run underneath in our tools. We've got our famous, if you don't know what to do, run Pracmon, here we go. And category is right, you already know, you learned that, so I don't have to explain that. Anything that will be written to the disk, I'm gonna get it. Lovely, so I'm saving the password right now. Disk monitoring is running. We already gathered almost 100,000 events. I'm gonna put some password here. Something, yes? Okay, so this is perfect. Now I will stop monitoring, I will enlarge it, and we have only 155 events where there was some kind of a write activity, and I can find out, and I already found, really interesting place in a registry where this password is saved. Yes? So, of course we have to see it. Now, let's do this, and let's jump to, because I want to see. So in registry, yes, I will be able, let me close this registry and maybe do this one more time. So jump to, hopefully it will open up. Here we go. I got the private key password, bang bang, and we can spot clearly here that that password looks like base 64. Now it could be, does it really, I mean, is it really base 64? No, calm down, it's not. If you actually decode it, which you can do, yes, you're gonna have some trash. Now here comes the beauty of Microsoft, yes? Not complaining, just laughing a little bit and being super ironic, yes? This way how we save data and how we encrypt data, yes? In Linux, there is a little bit of standardization. When, for example, you write data, you do this in a little endian, as a little endian, or as a big endian, so from one side or from the other side, yes? In Microsoft, doesn't matter. This way or that way, or this way here, that way there, and it's a big mess. So you have to actually find out if it's a little endian, big endian, like what is it? So here comes the interesting case, how to decode that. So I have actually built a little PowerShell script, and that's the one, where you are able to decode the whole thing. Just to explain, because it's actually very easy, I'm using the cryptographic provider, and I'm doing this. This is the key to success. Reversing the array to decrypt it. Because if you don't do that, you get a mess. If you reverse it, bang, password comes in a clear text. Let's see. So, first of all, you're probably wondering what kind of test.xml I'm having here. Well, this is nothing but IIS private keys. the ones that IIS used right now when I was saving this password. So IIS was engaged and said, oh, wait a second, I need to use this private key in order to, of course, well, do something on it and encrypt, of course, the whole data. Well, it is in this case going to be actually public key, but I need the private key to decrypt the data. And that's the whole case. Now, let's bring it on and let me show you where we can find such. It is actually more convenient to work with to work with the IIS console and the CMD, because what I need to go to is Windows, Microsoft.NET, Framework 64, version of Framework, lovely folder, right, by the way, ASP.NET, Rec IIS. ASP.NET, okay, here we go, ASP.NET _ Rec IIS. The sexiest tool in IIS. IUpCMD was from hell, yes, by the way, if you want to know, that's my personal opinion. This is actually pretty cool. Because it's a lot of features over there. One of those features is a feature that represents PX. PX is to export IIS keys. Yes, this is when you want to do backup of the IIS keys used in the store that is called IIS was here. No, key. IIS was here. And that IIS was key is the store. And now what we will do, we're going to save the data into C test.xml, yes? And in order to have the private key, I'm going to do as private to do that. Succeeded. Yeah, life is full of success. We can move forward. So succeeded means we got the key. If you want to know how it looks like, we will just do notepad test.xml, and this key looks like this. Yeah, so I'm going to use that for decryption. Ready? Okay. So, perfect. Yes, the only thing we could do is just to run the whole thing. Yes, so I'm going to select it. And the script that I had, yes, what it reveals me, it's a password that I was using underneath with these dots. Not in a clear text, but on the drive. By the way, there are even more places like that. Yes? So just saying, let's move on. So when we think about all those interesting places in operating system, of course, here comes the time for very, very interesting situation when we are talking about the cache credentials. Yes, what are those? So system scenarios. So first of all, let me tell you something, that if there is something written to the drive that is encrypted, it is actually written on the drive with something that is called data protection API. Very difficult subjects, but in the normal words, it is simply speaking an API that allows us to pass data through using different types of algorithms and save them on the disk in an encrypted way. Now, whenever we are thinking about how does it work, let me actually show you that on the very simple example of, well, our guy, which is actually here called Freddy. And in this particular case, what I will do, I will go to app data, yes, and then we've got Freddy's profile roaming, and I'm going to go to Microsoft's, and there are two very important folders that we have to know about. I know it's a little bit of theory, so I'm sorry, but without that we cannot pass further because it will not be clear what I'm going to do. So there are two folders. One is called RSA, another one it's called Protect. Protect, let's start from that because it's a little bit higher in the whole structure. If we do dir, yes, dir/a, we've got our credhis file, and we've got also the seed file. So this is the seed of Freddy, of our user. And if we do, if we go to seed folder, yes, dir/a, what we see over here, it's a set of, and here comes the mystery. What's the name of that? Nobody knows. So we name them, and we call them either master keys or key containers. So when you're going to see any article from us, yes, this is what we mean. And what is the key container? Because I think it's even a better way to name things. Key container, it's nothing but a bag when you've got different types of values that encrypt your private keys that are stored in the other RSA folder. Okay, so this is clear. So these are the containers that contain the key, that contains the keys that encrypt your private keys, that encrypt your whatever you choose. Facebook password, it's a good example. So long story short, if you delete them, you are kind of screwed. That's the case. But there is very interesting place that we found out. This is this BK Secure. BK Secure, well, it's our name, but BK, it's always there. BK, we call it a backup key, and it is actually called backup key. Imagine, now we're getting to the quite interesting part. BK Secure, it's a public key of the domain. Now, we encrypt with a public key, so that if someone has a private key, who is this? Then these guys will be able to decrypt our secrets. This BK Secure also encrypts your private keys, the ones that you use to encrypt your Facebook password, whatever encryption you use in Windows. So someone in possession of their private key is truly a master of disaster, and then you will be able to get your data. Now, let's have a look into the juicy part. What about these cache credentials, yes? So whenever we are thinking about, well, cache credentials, first of all, let me run psexec sid cmd.exe. These cache credentials, regedit, they are stored in here, security hive cache. And in security hive cache, you've got different values stored. For example, I have here and here. It means that I have two cache credentials. These are the values that look actually pretty weird. Yes, they are encrypted with the data protection API. And my question to you is, can we get the password from that? And how do they work? So let me show you something interesting. We're going to actually work on those cache credentials, and I would like to show you if it's possible to get access to the user's data with the cache credentials. But before we do that, first I need to show you actually a small theoretical slide. And that slide looks like this. That took us actually over 6 months to analyze in a binary way, bit by bit, literally. I mean, every single like tiny letter. So what is in there, and to reverse engineer cache credentials. I can tell you right now that cache credentials are not that dangerous, but let's have a look. So cache credentials are not any hashes or anything like that, as we might think, but this is the function that we have below, Microsoft implementation. This value, we call this MSDCC2, and MSDCC2, it's calculated using the function pbkdf2. I know it's an exciting thing about to know on at 6 p.m., yes? But regardless, we've got here DCC1 and the username. And this number, this 10,240, this is the number of iterations we run that function in order to produce a value for you. So this DCC1, it is actually like a hash value of your username and the hash of your password. So on the top of that, you've got another hash, and that is an entry to another type of a hashing function that produces you something. So are these credentials or not? To crack it, hard. Actually, uber hard, yes, right now, but who knows what's going to be tomorrow. But how do we get access to such? Yes, so let's have a look. How do we do that? So this is a pretty interesting scenario. In order to play with the cache credentials, and let's dig in, what I need to do, and I will do this actually using the offline mode, I need to dig into the user's profile. So what we will do, well, simply speaking, we will actually reboot this machine from the installation media, and I will pretend from the user perspective that I log on with the cache credentials. One more thing to show you guys, because that you might think that I'm cheating with something. I want to show you everything. Here we go. Yes, password is, yes, password. Yes, we all see. Okay, great. So enter, I log on. Okay, worked. So this is the password of the user. Now what I will do, I will reboot. Yeah, so as we said, everything is according to the plan, and I will reboot from the installation media, and let's move forward. And what I will do, I will actually replace those cache credentials with my own. And in order to do that, you need to have a tool that will calculate it in an exactly same way. Yeah, so this is the beauty of Hyper-V, but we are getting there. Okay, and we will, here we go, boot from that place. In the meantime, when we are booting, let me pretend that we will have no access to the domain controller, because otherwise our demonstration would be ruined. And we've got an interface that is not connected. And we will be, of course, right now editing those credentials. Now, what kind of tools I'm going to use for that? And well, how does it work? Well, first of all, let's go next. Repair your computer. Let's launch our CMD. So we've got troubleshoot, and then advanced options, because command prompt apparently is very advanced. And what we will do, let's go to my CQ tools on the C drive. It will be actually on the D drive. So CQ tools, let me enlarge it so that guys in the back can see everything super clearly. So font and then something bigger. Yeah, it should be, maybe this one should be enough. Lovely. Okay, and over there, what we will do, we're gonna actually, well, run, in my case, Kiwi Secure Edition, and this is our edition of Mimikatz, because we cooperate with Benjamin. Every edition that you have like that with Secure Edition, it means it's not discovered by antivirus. Yeah, so be careful because it's really beyond the ethics, yes, to use it. But who said we're supposed to be ethical when we are on a bad site? Yes. Regardless, yes, let's move on. So what we will do? Well, I'm gonna update this cache credentials. LSA dump and LSA dump. It is okay, okay, and then we will do cache. And then we will replace cache credentials with our own. Have a look. So it's going to be the D drive, Windows, System32, config, and then we need to do this too. System first, and then a next parameter, as we remember, because I already explained that, in order to save something somewhere, encrypt something somewhere, that our keys are spread across these two. So I need to, of course, pull here again Windows. Tab doesn't work, if you are wondering, so I have to type it. System32, and then it's going to be config, and then it's going to be... Come on. No. Okay. I get a t-shirt. And it says, what the heck? Yes? Who says it gets the t-shirt? Security. Who said this? Thank you. Yes, it's for you. If you need, like, this is XL, so we got more sizes, okay? It's waiting for you here, okay? But don't pick it now, okay? Like just later. Yes. Security. Thank you. Security. And a very important switch, which is Kiwi. And that's the one that will upgrade our credentials. Lovely, we're done. As you see, I said we have 2 cache credentials, and I didn't lie, we've got 2. So now it's time to roll. So what is interesting is that, well, let's see what we're gonna get. So I'm gonna continue. And I would like to show you that if we have access to the user profile and we take over those cache credentials, there is not much you need to be afraid about. Because Data Protection API is designed in a way that when we change the password that way, we will not be able to decrypt all those stores that I was showing you before, like Credhist and so on. So this will be actually quite okay, which I will prove to you by trying to pull passwords from Google Chrome, from the browser, and you will see that there is nothing. It's actually empty. So Freddy Krueger, yes, tries to log on, and what I will do, have a look. I'm going to run with the log on with the password Mimikatz, which is a different password. Question is, can I do that? And as you see, or you will see in a second, I should be able to do that. So this is not local account, by the way. Did you notice? It's a domain account that I'm logging on with the cache credentials that have been overwritten. Now, interesting part of that is that, let's have a look. I'm going to go to our tools, these ones, and there is a tool Chrome Pass. And this Chrome Pass, yes, will display me, well, the saved by user credentials, where you will be able, well, to see no password, but I will do something very nice over here in order to show you how to actually steal passwords from Facebook, Twitter, and everything from every single user from your domain. Okay, quite useful if you want to be on a bad site. So let's have a look. We've got here password empty. Yes, so we didn't get that. Now, juicy part. We could be saying, okay, this is not cool because we need to be on a domain controller first, blah, 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 blah. Yeah, well, sure. But if we are talking here per administrator that turned to be a bad guy, have a look what we can do. I got here Kiwi, and I got our new edition of Mimikatz, which is the Kiwi PFX, and let me run it. And did you know, and this is the cool part, that in the domain controller's memory, there is a very dodgy certificate, like uber dodgy certificate, that's there, and it's like expired, issued for 1 year, issued to nobody by nobody. Like, why is there? Is someone like spying on it? Don't get me wrong, I'm far beyond from any like plot, like someone is spying. I'm far beyond that. But truly, like, this is so weird. So let's have a look what's weird. Well, what I will do, well, first of all, privilege, debug, very important, well, privilege, debug, one more time, okay, very important privilege in the operating system that allows us to connect to the local security authority subsystems memory. And now what I will do, I will run secure LSA, backup keys, export, okay, and I get something interesting, yes? So these are the keys that I'm talking about. Now, if that doesn't work, in my case it did, but if in your case it doesn't work, yes, you can always do here LSA dump, okay? And the same command should also give you some kind of an information, okay? Because sometimes one of those doesn't work. Just saying if you want to be like 100% evil and effective, yes? So this is the case, and let's have a look what we've got in our stuff, yes? So if we go to Kiwi, we're almost done, Kiwi PFX, yes, then we've got those things. These are those certificates. Let me display it for you so that you see what do we mean, and I have already imported them before the presentation to the client machine to show you how we are able to decrypt the user's password. So we are almost done. Okay, this is the one. Nobody by nobody, issued only for 1 year. Like, what the hell is this? Like, this is a serious question. Okay, so, not even trusted. Like, what? So, okay, this is interesting. Let's have a look in this place here. So, two things to do in order to get this password of the user. Yes, and I hope you are still with me. Are you there? Yes? Okay, good, good, good. So, let's have a look. First of all, what we need to do, and we've got a very nice tools that we wrote in CQ tools. The tool is called master key. Let me do that. CQ master key AD. Where? Well, come on, come on, come on, come on. No, let me get there. There. This is the one. No. Yes, disk tools. Of course, master key ID. And that's the one that takes 3 parameters, yes? First, PFX, and I have this, actually, that particular certificates there. So this is the one that we can use this. So I already copied that, yeah? So this is our PFX, which contains the private key to decrypt the stuff. Now, we need to use something that we call file. And that particular file is actually the file that we get from the protect folder, because this is the file that contains master keys that will give us an access to the private keys to decrypt the password. Up data, okay, bank. We've got the profile of Freddy, Microsoft, protect, and then we've got those. Now, question is, of course, which one is this? And I can tell you that I've selected mine because I found it. You need to use one by one, but you can automate that process. This is actually this one. Shift, right click, yes, copy as path. And then this is pretty much the one that we will give as parameter here. Lovely. And then we need to specify the new hash. And the new hash, it's going to be, and this is our, well, next console that I will run, it is actually the hash that is calculated of the new password. So if I go to our, again, CQ tools, we've got here the CQ hash calc that takes 2 parameters, pass and user. Let's do that. Pass, it's cats. We need to be super correct. Of course, F Kruger, it's the, not this one. It doesn't matter, of course, but I just want to be super correct. And this is the one. So this is the MD4 used in Windows NT hash. Bank, we got it. And when we get there, we give that as a parameter. Enter. So that works nicely. Now, I have this tiny little command, because what has been generated, we are like one step further. This is the cool stuff in Windows 10, by the way, that you can like copy that, and it doesn't break the line. Yes, it actually copies the whole. I love it. Anyway, let's move forward. And what we have here is the AD modified. So this one we changed to old. Yes, dit.old. and this one, whatever, and this one we change like to the original one. Yeah, so this is the key. This is the key container that contains the key that we have to get access to in order to get access to our private key that will decrypt the Google Chrome password. Yes, bank, we need to give an attribute of system and hidden. Lovely, this is done. We go to the Google tool, we'll refresh, and we got the password. Can administrator be evil? Thank you guys. Thanks. Yeah, you see, I mean, this is quite dangerous, yeah? So we need to make sure who is our domain admin, so to say, because anyone that has access to the memory dump of domain controller, we could say, yeah, obviously, they can do everything. I agree, but everything means what? Like what? Like also get the passwords of the users, because a couple of months ago, it wasn't that clear. Yes, we could say no, well, passwords of the users are encrypted, whatever they have in their profiles in the browsers, this is actually encrypted. So what about the whole situation, yes? Well, answer is actually very simple here. Whoever makes a dump of the domain controller gets this dodgy certificate out that we have discovered, and this domain admin can literally, and I will be serious right now, violate people's lives. Because if you've got your Facebook, Twitter, whatever, yes, or maybe companies' applications there, someone can steal those credentials and technically spy on people. Prevention? Exactly, control. Who has access to the domain controller? Because making a dump not only reveals a lot of passwords, but also that tiny little fact that can be quite serious in the organization. Summary. So, you see that there's a lot of places where credentials are stored on the disk. Some of them are stored securely, some of them they're not. Some of them, like this, for example, require additional push, which is, of course, the certificate that must be exported from the domain controller's memory, which I wouldn't say that attacker will do it, which may happen, but it's more like an internal threat rather than anything else. Of course, whenever you are storing anything on the disk, remember that it's not wiped, yes? Unless you really wipe it many times, there's always some tiny little details that are there, and there are many different tools that can discover that. Example, the application that I showed you. We think we deleted something, but we truly didn't, yes? Private mode, the same story. You leave the traces on the disk. If you are wondering, by the way, if this presentation was interesting for you, and if you are wondering what to do when you're going to back home to get more information about that, you know what I'm going to say. Use Procmon, yes? Because Procmon with the category is right will tell you a lot of information what is stored on the disk. And when you change different passwords, save passwords somewhere, and so on, monitor that. Because Procmon directly sucks into the internet, is directly sucks to the ETW, event tracing for Windows, and this is the 100% source of knowledge of what's happening in operating system. ETW, yes, that's the answer for every question in IT. Okay, anyway, BitLocker, of course, and I have to say it, it's a prevention for this cache credentials things that we did, though we are working right now on a tool that will do this actually online. Yeah, so stay tuned, because research is continuing, research is not over. We were also interesting, how is it that when you store when you store profile in live, like Freddy stores profile in a domain, there was this BK secure key that was encrypting all the things. If you store profile in live, who knows your data? I don't know. But hopefully we will find out until the next year of NIC. And thank you so much, guys. Hope you're going to come to the memory session, because it is actually pretty interesting. I'm going to pull out our new research to the field, how to analyze memory dumps and how to do it practically, so that when you leave the sessions as well, you're going to have something that you know, and you can start doing this immediately when you get back home. All the tools are available on our website. Thank you so much, and I hope you enjoy it. One more thing, of course, I have to mention. Please fill out the evaluations with the cards. And we've got T-shirts for technically first 10 guys that get to the glass paper booth, which are like centralized. We cooperate with glass paper, so I have to say it. And there are different sizes, even for women, because we thought about that. Thank you so much. Hey, pick your T-shirts, yeah?